Hi guys, how are you today? We're back to you for calculus classes, calculus 2 classes. Our class today about applications of integration, volume of solids of revolution. Today we'll focus on disk and washer method. We will see how we can find the volume of any solid when we revolve it about x-axis, y-axis. When I say x-axis, I'm saying about a horizontal line. And we have to remember x-axis mean y equals 0, y-axis mean x equals 0. Again, I'm going to repeat. X-axis mean y equals 0, y-axis mean x equals 0. Then, if you have any question, just let me delete this. Okay. Delete it. Okay. And don't forget we have, if you have friends, we have SAT classes running soon, a daily base. Just please subscribe to receive all the notes about calculus 2. I'm going to keep going with this application till I finish it. Don't forget to like and subscribe if you want. Okay, let us go to our class. In calculus 2, application of integration, volume of solids of revolution, disk and washer method. Let me just explain what the difference between disk and washer. When we want to revolve one function, okay, about x-axis. Now let's talk about what? Revolving about x-axis. And remember, x-axis mean y equal what? 0. Y equal 0. Also, we will revolve any function about any line parallel to x-axis. Any line parallel to x-axis will be y equal any line equal a, where a is a constant, could be 2, could be -2. Then our revolving will be around x-axis like this, if we have, or if we have another line, if we have x equal negative, we'll see how we can revolve this when we have revolve the function about this line if it's positive, or this line if it's negative. Then we can revolve the function. I'm going to show you the function. Okay, about this, the same way. Then we have a function. We need to revolve the function either about x-axis, or about this, or about that one. Now revolving, and we still talk about disk method. Disk method, we use it when we have one function. We're gonna revolve one what? Disk when we have one function. We talk about disk method. Disk method. The rule for this, only when we revolve about around a to the b pi, you can put pi outside, And the area will, and we take a disk, small disk like small circles, fx squared dx. Like, yeah, from where this comes? This comes from where? Area of the circle, equal pi r squared. Okay, look here. The r here is my function. R is what? Equal my function f of x. Now we talk about revolving about x-axis. If we have this function here, if we have this function, and this function goes from a to the b, we need to revolve from a to the b. If you take cross section, if you take a cross section, let me make right from here to here, right, and revolve it about x-axis, look what's gonna happen. We're gonna have a small disk like a circle. Let me just use different color than the blue and show you the revolving. You see this guy here will be like this. Now when you revolve the green line, take small slice, small piece, just slice, small slice here, and I'm not that accurate, let me just erase this guy here a little bit. Let's fix it. And we have to take a little bit accurate, and you see that here. I think this is gonna be better, right? And here, from here to here, this is the radius, what we call it R. This is what we call it what? R, the radius of revolution. If you take it down here, you see this guy? This is my what? Disk, which has a radius equal to R. R is what? If you have this x, right? And here, the R is the value of the function at x, which is what we call it, the R equal f of x, which is this function. Okay. Now, let us take some example. Explain this, okay? Let us take some example. Let us revolve some function about x-axis. Okay, now I'm going to take a function, easy function, y equal, find, I'm going to say the problem, find, first maybe he's going to tell you like, write the definite integration, define, write and evaluate. Let us write and evaluate. Write and evaluate the definite integration integral represent what? The solid form, the volume. This is going to be for all my problem. I'm going to write it one time. The volume of the solid. I'm going to write it one more time. One time. The solid formed by revolution, the region formed by revolution region. Okay guys, region of the function f of x equal 1 over 3. 1 over 3, let me just get my function. 1 plus 2x and the lines, line x equals 0 and x equals 4. If you want to sketch and to see this, if you want to sketch and to see how this line look like, how this line look like, okay, let me just show you how this line look like. One over 1 plus 2x, right? 1 divided by square root of 1 plus 2x. 1, you said, plus 2x. Okay, and I'm gonna graph my 0, x, look here, x equals 0, and x equals 0, and the other line, x equals 4, x equal 4. You see the area we want to revolve about x-axis. The revolving will be about what? X-axis. Just, I'm going to show you. Okay. You see, we're going to revolve this guy here. You see this guy? This one. This distance, I'm going to try to be very careful in graphing it. Exactly this area, and my my depth is gonna be like this. It's nice. Let me just fix this a little bit. Small eraser. We're gonna start from this. I'm gonna take the pen a little bit. Now we're gonna go from the same thing. We see this point, it's here, and this point is 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 here. You're talking about this line. If you can see it well. Okay, good. Now when it's revolved, it's gonna revolve like this. You see that, guys? And the first class, I mean, just to see, after that we're gonna solve more problems. But for today class, and every time I will give you a hard problem, so I'm gonna prepare one problem, hard one, and I'm gonna make it solved and ready for you. Look here, you see the radius? My radius here is R. Radius from here to here is what? You see the radius change because that what? You see the R. You see the R changes. R is what? F of x. The function f of x, which is the given function. Applying the formula, integration, from where to where? From 0 to 4, pi f of x square dx give you the volume, what you're looking for. Volume equal pi. Now my function, if you remember, my function is here, 1 over, I'm gonna square it in the side, 2x, when you square it, becomes 1 over 1 plus 2x. Then when you square all this, it's gonna be 1 over 2, 1 plus 2x. 1 plus, let me just make some numbers more, okay? And take a different color for this. Okay, red, okay. Then volume equal pi integration of 1 plus 2x. Now, in this level of calculus, you should be ready to solve this problem. You can use your substitution if you don't want to, if you don't know how to do it, but this is, if you do the your substitution, u equal 1 plus 2x, and du equal 2 dx. Then dx equal du over 2. And this guy becomes pi. I left the limit. I'm gonna 1/2, you can take the 2 out. You can take the 2 out. I'm gonna take it in different color. 2. And 1 over u du, which is ln u. Then this equal pi over 2, right? 1 over u du, which is ln u, which is pi over 2. Bring u now, ln, what's u? U is, in case you put absolute value, u 1 plus 2x. U is what? 1 plus 2x. From where to where my limit now for x? For x. Yeah, I don't hear you good. From where to where? From 0 to 4. From 0 to 4. Pi over 2, let me just fix the 2 here. Pi over 2. You plug now the 4, then you plug the 2. Let me just do it for you here in different color. Pi over 2. Pi over 2. So plug the 4. 1, look here, open bracket. If you plug the 4, 1 plus 8 is 9, right? Ln 9. Ln what? Ln 9 minus ln 1. Right? But what ln 1 equals? 0. Everyone know that what? Ln 1 0. Then pi over 2 ln 9 volume. This is my answer. Okay. 1 second. Okay. Take 1 second to see. Then my function. This is my function. The revolving about x-axis. The formula, I give it to you in the other board. I'm going to back to that board, which is integration pi for this disk method from 0 to 4 f of x squared dx pi 1 over plus, right? I left the limit because I need to use substitution. In this case, 1. I always square and do the algebra on the side to make your function easy, okay? And 1 plus 1 square is 1. When you square the square root, it becomes 1 plus 2x. U 1 plus 2x, du equal 2 dx, dx du. Okay. Here we have the function. We need to integrate it. We this our substitution. U equal 1 plus 2x, du equal 2 dx, dx equal du over 2. And we go back to this, the 2 here. This 2 comes out because it's constant. 1 over u du. Everyone know what 1 over u. 1 over u is ln u. Then pi over 2. Ln, bring u back. U is equal to 1 plus 2x. Ln 1 plus 2x from 0 to the 4. Then pi over 2. Plug the values 4 and 4. 1, 2 times 4 is 8 plus 1 is 9. Now again, 2 times 0 is 0. Ln 1 is what? 0. Ln 1 is 0. Okay. And leave this, we need it later on. Okay? Good. Okay. This is page 2-3, view page, first page. Okay. Then this is the first problem. Okay. We're done with this problem. Second one. Let us see another easy problem or another problem. Let us see. Find the volume of the solid, right? To see what's gonna happen. Now the second example, we have y equal square root of x. I need to find the volume of the solid formed by the function square root of x, this function, and y equals 0, which is x-axis, and y equal 5, and x equal 5. Then I need to find between this function, square root of x, square root of x, and which is square root of x, y equals 0, which is x-axis, y, which is x-axis, this y equals 0. The same name. If I say y equals 0 and x equals 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, let me just make it nicer. About x-axis. X equal 5, 1, 2, 3, 4, 5. About this line, let me just give it different color because I don't want you. Okay. And this from 0, then my integration goes from 0 to 5. Well, the revolving is going to be about this. Now look guys, what I'm going to do now. I'm going to take another color and show you how the revolving will be. You're going to have an image like this. You see, it's almost the same. Just let me look. And look here how this nice volume will look like. Wow, right? It's good. And everything will be the same. You see the R, my R here, my R here, here, from here to here, changing, right? Which is the same as f of x. Then, depend on the rule I give it to you, volume equal pi, integration from 0 to the 5, f of x square dx, which is pi, integration from 0 to the 5, f of x is square root of x square root of x square dx, which is becomes very easy integration to deal with pi 0 to the 5 x dx. X dx. Now equal pi, integration of x is x squared over 2 from 0 to the 5, which is pi 25 over 2. Or you can write it 25 pi over 2. Okay, what happened if I want to revolve this, the same function, if I want to revolve it about the x equal 5? The revolving will not be about the y equals 0. Is about different function, right? About what? X equal 5. That's what we're gonna do next time. We'll do revolving the function about different line than y equals 0, which is x-axis. I mean by this, we're gonna revolve it about a line above x-axis or below x-axis, like y equal 2, y equal 3. See you next time. Have a nice day.